So, just like we talked about with our simulation up here, now you're going to get to go and just try to see these things in real life. Now, we don't have the best equipment in the world, so it's going to be a little bit of a challenge. That's part of the fun of it, right? So there's actually two different setups that we have for you to see spectrums of different elements. We have several gas discharge tubes set around, and you can see the big power supplies around. And we're going to practice with these guys too. So, this high quality piece of plastic is called a spectroscope. And the way, let's stand up and kind of crowd around over here. Front row, you guys are good. We'll stay there. You can see back row, crowd around. So, high quality piece of equipment. Label goes on the top side. If there isn't a label, basically what you're looking for is there's a slit in the front here and then a longer one here. I'm trying to touch it. There's actually a piece of diffraction plastic there. This one's already, that works. So you're going to point this slit at the light source. But then you're going to look this way at the grating. And you kind of have to tweak it sometimes, and we're going to practice first, but you have to tweak it until all of a sudden then you should see the spectrum. And there are numbers in here, and the colors should line up with those numbers. And so on your lab, you'll see that you have kind of those numbers. Oh, are they backwards from what's on here? They are. Not. So that's good. That's good. So you're going to try to reproduce on the lab the spectrum that you saw. Now, probably doing this in pairs is going to help, because you can have a caller and you can have a marker. And I'll get out colored pencils if you don't have any, because you want to put the correct color at the correct place as best you can. I want each person in your pair to look at the sample and to see it, but then probably have one person look at it and call it out and say, okay, I got a purple at 4.5, and I got a teal green at 5, and I got a green at 4.5, et cetera, and try to have them draw it, and then everybody copy it. So, when you look at these power sources, this high voltage, if you stick your finger in the wrong place, you're going to have bad hair day. Okay? So, you just turn the power switch on at the side, and then you can see the color of that one. This is actually one of our unknowns. We have two unknowns. You're going to pick one of them, and you're going to do your best to try to identify that unknown from its spectrum compared to our reference chart up front. Okay? If there's nobody around looking at it, please turn those back off because they don't last forever. Okay? The other setup that we have is a flame test, and this was traditionally we did flame tests where you'd have a Bunsen burner, and you have a little wire loop, and you'd dip the wire loop in that powdered chemical, and you'd stick it in the flame, and it would make a different color. We've got a little bit different setup, and what I'll do is kind of call back smaller groups of you as I start setting them up, and I'll talk you through how they work. But then you'll see we'll have flames back there that are different colors, and you can try to get a spectrum on that. They are harder because it's not very bright. What I'd like you to try to do now, we've kind of got spectroscopes lying around. Go grab one, or grab one for every two people. Just grab one and borrow it real quick. Because I want to practice. A few of them don't work. We've got to weed those out. Yep, your partner's who you're sitting with.
Oh, okay.
So just grab one and come, no, come over here. Don't turn those on yet. Turn that back off. Come over here. And I want you to look at this light through the spectroscope. So again, you put the slit on the right, you point the slit at the light, but then you look to the left inside there and tell me what you see. What do you see? Anybody get something?
Rainbow.
We should be getting a complete spectrum, like a rainbow. Okay, this is white light. It's comprised of all of those colors. We're getting all of those frequencies coming out, so you get a continuous spectrum, like this guy up here. If you're having trouble seeing that, get a little closer, and then wave at me. I want to make sure that all of you can see that rainbow. Anybody having trouble with that? Anybody have not had a chance to see that yet? Thumbs up from everyone? Are we good? Seriously, because if you can't see this one, the other ones aren't going to work. So we're good? Everybody good? All right, now let's try another one. Look at one of the fluorescent lights and tell me what you see. You see a bright line spectrum? It's not a complete spectrum, is it? So do I fire along mine out too? So see if you see the same thing. It's kind of what I was calling out earlier. I see a red at about 6.5. I see an orange just to the right of that, maybe 6.4. I see a bright green at about 5.8. I see a blue at 5.3-ish, and a purple at 4.7, 4.8-ish. Trade it around. I want to make sure everybody sees that. Anybody having trouble seeing that one? Okay, so what you're looking for are more like those. Okay? And when you have those, and you can kind of double check yourself on some of the knowns, come over and say, gee, did what I draw look something like that? Oh, this is what's reversed. This chart is reversed from what we have in our paper and what we have in here. Okay? So just turn your page upside down, and you're good to go. And you come compare it to this. Okay? So I think we have two unknowns and 1, 2, 3, 4-ish other tubes out. You only have to do 3 plus 1 unknown. So we have extras out to try to alleviate a little bit of crowding. Again, go in your pairs. Each of you look at the spectrum and then do your best to recreate that with colored pencils in the correct spacing. And then I'll start getting the flame test set up back there. Please don't touch that stuff.
What the spectroscopes? I was just
Okay.
making sure mine wasn't defective.
And I'll call you back in smaller groups as I light up each one and describe the method that we are using with those. So we need to get all that data today, and then probably you'll have time to start working through some of the questions on the back. Yes?
Should we just keep one of these per group, or should we put them?
I think what we're going to try to do is to leave them at each, instead of having you carrying them around, because then they end up everywhere. So put them back wherever you just borrowed it from, and leave them at that station. Any other questions? Come crowd around. If you want to be behind me, that's okay. The way we used to do, or one way to do flame tests on a substance, and this is a way to identify an unknown, one way to identify an unknown substance, right? So if we have a salt powder, we could, we used to have these metal loops, right? And we could dip the loop in the powder and shove it in flame, and it will turn the flame a different color. Well, then it's a real pain in the neck, because then I have to really clean that wire loop. I have to go into acid and water and acid and water and water and clean it and clean it and clean it, and then I could go to the next one. And that got to be kind of a real drag. So this method does the exact same thing, gets us the same result in a little bit different way. So here's what I'm doing. I'm taking some hydrochloric acid, which is mostly water. There's acid in this. So I'm pouring that in this petri dish. I'm going to put some of our unknown salt. Now, in this case, we know what it is because we haven't seen it yet. So this one is strontium chloride. Now, the chloride isn't going to make a difference. And what you're going to see in all the ones that we set up is that they are all something chloride, but we get different colors. Well, that means the chloride isn't affecting it. It's the metal component that gets us our color. So I'm going to dump some of this in here, and what happens when you put salt into water? Yeah, it dissolves. So the same thing here. This stuff is going to dissolve because this acid is mostly water. And then I'm going to put a little chunk of zinc into here, and the zinc will react with the hydrochloric acid. It's kind of dark, but can anybody see what's happening with that? I put the zinc in right there. It's probably too dark. It's bubbling, okay? So the bubbles are actually hydrogen gas that's coming up. Now, as that comes up, that gas carries with it some of the dissolved strontium, and it's going to get sucked right into our Bunsen burner flame. So, first off, I want you to see the color of the Bunsen burner by itself. Just correctly here. Okay, so how would you ignore the yellow? That'll kind of go away. How would you describe that color? Blue. So that's, you'll learn how to light and adjust these Bunsen burners, but you're looking for kind of that violet on the outside with a brighter blue on the inside. See a little better defined there? All right, so let's see now what happens to that flame when we put it on top of this. And it'll do a little, got a little flash of red, and if I can do this. Ah. You see the new color? Ignore the orange, that'll go away. That's just junk that's in our burner. What color do you see in the flame? That kind of reddish pink, and that is a characteristic color for strontium. Now, you can try to get a spectrum on these, but you may not. It may not be quite really a bright enough light source. Okay, there we go. And I'll get the other one set up, and you can kind of follow me around and get set up. Thanks.